Okay, sorry about this this break and this being a part 2. Hopefully you've made it here from part 1, so you've already seen problem number 32. I didn't feel like I did a great job explaining 34 on the first video, so I'm going to give it a try again. Here we had the point 0, 1, and 4, 5, and we were able to use it in example 32. This is the same thing. We're given 0, 5, and 3, 1/2. And what we learned back in this problem 32 was the a value in this formula, and this is just very, very typical of exponential growth. We need to know the a value, and that is the amount we start with, because when I put in 0 here, I get e to the b times 0, e to the 0th 1, so a just equals the y value. The y value is 1. 1's our starting value, which tells us by the same reasoning, if I have the point 0, 5 on a graph, let's see, 3, 1/2, somewhere about in here, and we got this exponential growth problem. It tells us 5's our starting point, so we can already go straight to y equals 5, e to the bx. And then we can put the second point in for x and y. 1/2 equals 5, e to the x is 3, b times 3. And we need to isolate our exponential, so that's e to the 3b equals either 1/2 divided by 5 or 1/2 times 1/5, or 1/10 equals e to the 3b. And now that this is isolated, we can take logarithms of both sides. Of course we would use ln here, and we get ln 1/10 equals the exponent that would turn e into e to the 3b. This is 3b, so b is ln 1/10 all on 3, giving us a final formula. Let's back out of this a little bit. Giving us a final formula of y equals 5, our starting amount, e to the exact value, ln, I'm going to go 0.1 on 3 times x. So this ln 0.1, we should realize that's a really, really tiny number. To get to 0.1, we're going to be going backwards here. This is going to be, it takes a negative value to get to 0.1. So that does indicate that we do have this shrinking going on, this depreciation. So with that, here's your assignment, and that was a short little part 2. If you just jumped on and saw that one first, there's certainly more explanation about that particular problem back on as I go through number 32. Thanks for tuning in.